Hello everyone, welcome to Jujutsu, or JJ, a state-of-the-art version control system. So, a bit of background before we dive in. Version control systems have two primary goals: provide a rich, detailed history of your code repository, and enable collaboration between a however large amount of developers on a single project. To do this, version control systems generally have four main functions. 1. They track local changes. The version control system should keep a record of every change you make to your copy of the repository. Changes include editing lines of code to adding and removing files. 2. They should provide an abstraction for groups of changes. In most cases, the number of individual changes is very large, so the version control system should provide a way to usefully group these into more manageable chunks, like a commit in Git. 3. They should provide complex manipulation of changes. Imagine you have two copies of your repository, one with functionality A and one with functionality B. If you want one copy with functionality of both A and B, it is important that your version control system can do that easily, or as easily as possible. It usually does this by comparing the changes in each copy. Finally, they need to support synchronization with an online remote. This means that they should provide a way for you to upload your code to some server like GitHub, and this copy should mimic your own. For collaborative projects, this server provides a central hub for developers to work from. Now, a few examples. There's Git, by far the most famous and most widely used. There's Mercurial, which is a bit less well known but still used by some big projects like Firefox. There's Subversion, and there's also TFVC, which is used by Azure. Okay, so now Jujutsu. What is it, how does it solve those problems, and how do you use it? JJ is a CLI-based tool, which just means you have to interact with it via a command prompt or terminal. It is 100% Git compatible. JJ uses the same internal representation of repositories as Git, so switching from Git to JJ or vice versa is very easy. And in your development team, different people can use Git or JJ as they choose, and it'll work fine. There's no technical overhead required to switch to JJ. This compatibility also solves the technical problems mentioned before, as it can kind of piggyback off of Git. While this is a CLI-based tool, your IDE might have extensions, like Visual JJ, that can provide a graphical user interface for it as well. Okay, so how would you use it? I'll go through the technical details later, but basically, you ask it to start tracking a folder. It'll then initialize a root commit, which is immutable and always empty, and then create a commit for you that adds any files that currently exist to the tracking system. This is synchronized to your working copy, which you can interact with. So, your working copy is always associated with an existing commit in JJ. You can always change which one, and choosing which commit this is reverts all the files on your machine back to that state, and then any changes you make are automatically added to that commit. If you have later commits that depend on that one, so descendants, the changes will be applied to all of them automatically. When you want to work on something new, you probably want to create a new commit. By default, this will be a descendant of the working copy commit, but you can specify any. This sounds simple, but this is actually very, very powerful, as you can create branches by creating multiple children from the same parent commit, or merge branches by creating a child commit with multiple parents. Of course, the latter will usually result in conflicts, which we will discuss shortly. So, let's talk about what some differences are between Jujutsu and the current most popular version control system, Git. Git has a staging area, or index. This is used to specify which changes should be included in the next commit, as you may not want all of them to be added. Well, in Jujutsu, your changes are automatically added to commits, so something like an index can't work. Instead, they provide commands that let you easily move changes from one commit to another. With the right commands, you can even just replicate index behavior using JJ, if you prefer. Git has branches as a feature, while JJ has them as a product. I'll try to explain what I mean by this. Git requires you to have a current branch that you're on, and that receives any commits you make. It requires you to name any branches you make, and has a specific command for changing branches. In short, Git gives branches special treatment, as if it were a feature, that the user needs to learn to become an adept with Git. JJ doesn't do any of this. Creating a branch is the same as creating a new commit, the only difference being the parent commit already has children, and you can just check this by running JJ log to see the commit tree of your repository. Checking out a commit on another branch uses the same command as checking out the parent commit of your working copy, or any other commit at all. JJ doesn't require you to name them, as it turns out a lot of the time, commit messages are more informative than branch names. But if you decide to, JJ provides bookmarks that you can use to track branches of interest. Branches are like a well-supported product of JJ's behavior instead of something completely new the user has to learn. Git stash. This is basically useful when you want to work on or look at another branch, but you have uncommitted changes. Git requires you to commit them before changing your current branch, otherwise it could lose them. But if you don't want to commit them for whatever reason, you can stash them instead. JJ having changes automatically committed or immediately bypasses this problem. The commit you're leaving behind will be as half-baked as it would be in Git, but this is always true at some point, whether you're actively working on it or not. This is a normal part of JJ's workflow, which is not true in Git. In Git, you can write commit messages only when you stage and commit your changes. In JJ, you usually create a commit, then start working. This means you can write a commit message before writing the changes, which could be useful to keep you or collaborators on track. JJ never forces you to write one though, so you can just wait until you feel like it. This is pretty similar for conflicts as well. In Git, when a conflict arises, you must resolve it immediately. In JJ, you can set aside the conflicted commit. Of course, you can still resolve it immediately, but you may not want to. Reasons may include working on another section while a team member pushes a fix, or this particular commit just becoming unimportant. Since descendants automatically rebase, you can even create and work on descendants of conflicted commits, and when a resolution arrives, it will just propagate down the chain. Overall, JJ seems to provide a simpler but more flexible workflow for approaching version control than Git. Alright, let's get started. I should have mentioned this earlier, but Jujutsu is an open source project maintained by Google. It's completely free, so we can immediately just try installing it. You can access pre-built binaries, select a place you can just download it and extract it, at the link in the top right. This link also contains detailed installation and setup instructions. You can instead build JJ from source, but this will require Rust if you don't already have that. Once you do, just follow the instructions on screen for your operating system. If none of these seem to work for you, again, there's more information in that link. Many options are listed here. You only need to perform one of these steps that say they provide the latest release. Once you have JJ installed, you probably want to set up your profile, as shown here. This information is primarily used for being attached to commits, so people can tell who wrote what and can contact the person if necessary. When you actually want to start using JJ, it's very similar to when you would set up Git for a project. You can see these commands are actually just the Git commands prefixed with JJ. For those unfamiliar with Git, Git clone takes the GitHub URL as an argument, copies the repository from there to your own machine in a subfolder, and starts tracking that subfolder using Git. Git init simply asks Git to track the current working directory. The JJ prefix just means that we want to use JJ instead of Git. You can also use the collocate flag in the command to tell JJ that you want to use both Git and JJ. Okay, now let's see how it works in practice. To start with, I'm going to clone a simple repository. And then open this in whatever IDE. Well, here we go. The repository I cloned just contains this file. This .jj folder was created by JJ, and you can safely ignore it. Very often, your repository will have files that you don't want JJ to track. In this case, you should use a .getignore file, in which you add names of all the files and folders that you don't want to track. This is exactly the same as it is in Git. Now, let's open a terminal and start with some basic commands. The command I use the most is jjlog. Let me break down this command output. Okay, there's a lot of information here. On the left is the directory structure. The tilde means some commits have been omitted to reduce visual clutter. The @ is a symbol that always refers to the working copy commit. Other nodes will also always be commits, with various symbols depending on their status. Clearly, there's metadata attached to each commit telling us when and by whom each one was made. This pink word here is what we call a bookmark, and is what JJ has instead of named branches. Now, there are two random looking strings on either side. The one on the left is called the change ID, and the one on the right is called the commit ID. You use IDs as arguments in commands to refer to specific commits. The difference is that the one on the right changes every time you make a change to that commit, so you can use it to refer to a specific snapshot a change ID could not. Change IDs are probably what you'll use more often, since you don't usually need that behavior. The full ID is much longer than is shown, but you don't have to type the whole thing, only the shortest unique prefix. This is shown in color here and here. The second line tells us whether a commit is empty, that is, has no changes, and its commit message. Since we added a getignore file, our commit is not empty, but we haven't written a commit message either. Let's go and do that now. To do this, we'll use jjdescribe. Jjdescribe is very similar to git commit in how it writes commit messages. Without arguments, it brings up a terminal dialog where you can write multi-line commit messages. Only the first line will be shown in jjlog. In my case, I'll use the im flag to pass in a single line commit message. We can now see it when we run jjlog. Another useful JJ command is jjstatus, which shows us which files the commit has added, modified, or deleted. As you can see, we added gitignore, but the junk file is not shown here. It also gives us some information about itself and all of its parents. Now, let's create some more commits. To do this, we use jjnew. I'll pass in an im flag to write a commit message for them immediately. If we open up the log, we can see they've both been added and are both empty. The working copy is the latest commit. Now, let's say I want to work on test 1 instead of test 2. We can just say jjedit and then the prefix of the change ID, in this case v. And you can see in the log, @ has moved back down to test 1. Let's add a line saying goodbye world, so the commit is no longer empty, and go back to test 2. We can see that the readme still contains goodbye world, even though this commit was not directly updated. The change has been automatically rebased to all of test 1's descendants, so just test 2 in this case. This makes sense if you think of commits as a collection of differences in state rather than a state itself. JJ also notifies you in the command output. Okay, let's move on. Since the other commits don't matter right now, I've filtered them out of the log. As the commit message says, I want to make this message nicer. To do that, I'll create 2 branches. That just requires calling jjnew twice, with s as the parameter. We can see this has indeed created 2 branches. I've made changes to these commits so they're no longer empty. The top line now says, how are you? And the bottom line says, best wishes. Now, I'll merge these changes into one commit by creating a new commit with 2 parents. Both parents are shown in the command output, and our readme now has both changes. Okay, I've created a similar situation, but now I'm going to try rebasing instead of merging. To do this, I just have to use jjrebase, like so. The commit after B is what gets moved, and the commit after D is where it moves to. I'll show you what I mean in the log. As you can see, R has moved onto K and now contains changes to both top and bottom lines. You can see the top line has been changed to just hello, and the bottom line has just been changed to goodbye. While sometimes changes can be merged automatically, very often it results in conflicts that you have to resolve manually. In this example, I'll merge the 2 branches, each making the readme better or worse. As we can see, a conflict note has been added to the commit, and the readme itself now contains conflict markers. To resolve a commit, you can either edit the conflict markers directly inside the file, but a more user-friendly way to do it is to use jjresolve. This opens a terminal dialog, which you can use to mark which changes you want and which changes you don't. In rare terminal fashion, you can actually click on these menus to show what actions you can perform. This dialog will list every file that has a conflict. You can open individual files by pressing F. This gives you a more detailed overview of what the conflict in each file is. I can now just click through and then select the changes that I want. And then proceed to confirm. And voila! I kept the changes that removed the original message and added the new nice ones. As we can see, the conflict node has also disappeared. Now let's try and push our changes. First, we need to set a remote, so of course we'll use jjgetRemote. As you can see, you have to give your remotes a name, and here you can quickly list them. Okay, now let's try pushing to main. It says that no bookmarks were found, which is JJ's version of named branches. Let's fix that. There's just jj bookmark, create, the name of the bookmark, and you have to specify a commit where this bookmark starts. We can now see it in jjlog, it's right here. And now we can push just fine. So there we go. We have to use the allow new flag because it's a new bookmark, and we have to specify which remote we want to push to. And now if we go to GitHub, we can see the changes and branches we just pushed. There's another thing I want to show you. I've created another commit updating the branch, so now let's try and push this to main. The reason this happens is because the bookmark doesn't move with us when we create a new commit. This star means it has unpushed changes. And there we go. Okay, it's time to wrap up. I've given an overview of the bread and butter of JJ, but there's still a lot more to talk about. In particular, JJ supports moving changes between commits very well, with commands like jjsquash, which can be useful for defining a proper workflow to organize your changes to a fine level. JJ also has functional undo and redo for commands, as well as an operation log with which you can restore to previous states. The last thing I want to mention is revsets. Many JJ commands like jjnew take a commit as a parameter, and most of the time this is the working copy by default. However, you can always use an R flag to specify any commit you like. To support this, JJ provides a custom language of riv sets that let you refer to a well-defined set of commits. For example, at is technically the working copy commit riv set, and earlier this video I used JJ log with s::: to only show the commit s and all its descendants. Riv sets are extremely powerful but relatively advanced tools, but still worthwhile to take a quick look into at least. You can see what I did myself on the repository I pushed you. Feel free to play around a bit. Since JJ is relatively new, there isn't a lot of third-party content on it. That said, the documentation is really helpful, and I would also recommend Steve's Jujutsu tutorial you can find online. Have a great day, and thanks for watching.